Look at an example. We have a vector A equal to and B equal to the question could be as simple as find the angle between A and B. Okay. And you can do it several ways. You can do it, think about it like this. You have A dot D is what? A B cosine theta, right? This implies cosine theta is A dot D divided by AB. Alright? So A dot D is simple. Let's look at this stepwise. A dot D is 42 minus plus okay, and this will be equal to 1392. Okay.
How did you get the K as being 5?
This is 18. Okay. So it is simply we cannot spend much time on this. I need you to figure this out. Okay? Is it simple? Yes? 1392. So this is 6. Sorry. Alright. What is 8? Don't use your cell phone. Anybody? One square plus 36 or 6 square plus 18 square. Right? And B is square root of 42 square plus 69 square plus this is 19 and 1. So if you substitute this, you're going to get cosine theta is equal to 1392 divided by 19 into 12. The angle you're going to get here is 54.77 degrees. Okay. Second question would be, find the projection of A on B. Alright. What is projection? If you have a vector A and you have a vector B, what is the projection of A on B? A dot B.
Yeah.
Okay, it's essentially the shadow of A on B if the light is vertically, if light is perpendicular to B. Got it? So what you're going to do is you're going to draw a perpendicular passing through this point, but it's perpendicular to this line. Okay? This is the projection of A on B. That makes sense? What is this component? How do you calculate this component?
You use Pythagorean theorem. So, this is the right triangle, you use Pythagorean theorem. I mean, you put 90 degrees right there. So I'm saying you use Pythagorean theorem to find that side. Right there. But I don't know if you're trying to do it vector or
Vector.
Oh.
A sine B. So this would be your theta. Okay. A sine B would be A sine theta would be this component, right?
Yeah, so
This component would be A
Cosine.
Okay. So what you're going to do is, the way you're going to find the projection is, you're going to do A dot B. But you're going to do A dot B. What does this mean? Caret mean? It's a unit vector. Okay. So this, what is A dot B? A, B, cosine theta. What is B here? This is the same as A cosine theta. Why so? What is the magnitude of a unit vector? 1, right? Magnitude of any unit vector is 1. Okay. Just a reminder, this is a vector. What is this? vector of B. And how is this defined? All this has been done in lecture 1. Okay. Now, how do you find the projection of A on B on this? Right, so you have two ways. Okay, what are the two ways? Tell me what are the two ways? One is, can you do this on the left hand side? Because you know A, you can calculate B, the unit vector of B. Can you do the right hand side? You know what theta is, right? You can calculate A and find out the projection. Okay? So how would you do the left hand side? You would just say, first you need this B, right? What is this B? It is 42 I minus 69J plus 98K divided by square root of 42 square plus 69 square plus 98 square. Okay, so you divide each component by the magnitude. You're going to get I'm just going to keep it like this. What is A dot B now? It will simply be so this is 42 by 19I minus 69 by 19J plus 98 by 19K. Okay? And then you're going to, if you do this, you're going to get, how do you do this? You simply multiply, right? 1 into 42 by 90 minus 6 plus 6 into minus 69 by 90. Got it? It's simple, right? So if you do this, what is the output of this?
You asked me if it was a vector. Yes,
Mhm.
vector.
Is it a vector?
Yes. Because A is a vector.
Well, it's a dot product. It results in a state. Okay. It will be 10.96.
How do you get 10.96?
You just do one, we did it like this, right? If you're exactly doing this, you're dividing this by, the other way to look at it is you're dividing this by 19. Does that make sense?
Why are you dividing by 19? So why are you dividing by 19 and not 12?
Because, oh, you're right, actually. This is
127. It's 127.
yeah, this is 19 actually. You're right, Joshua. Now it makes sense.
Yes, sir.
So you're dividing this by 19.
It's 127.
I got 127.
B, the.
You got 127?
Yes, sir.
For B. Instead of 19, I got 127. Yeah, for
B. For the magnitude.
This one?
Yeah.
Did you get for A? Well,
So you divide this by? You're right. So this is 127. My bad.
19 for the first one, too.
yeah. 8.
A is 19, is it?
Yep.
I'm a little off today.
So you're doing the same thing as 8.
Right. It will be what? It will be, instead of, look at it like this. It will be 1 into 42 by 90. Right? Minus 6 into 69 by 7, not 90, but 127. Got it? 18 into 98 by 127. So you're taking all of this, instead of doing each of them by 127, if you just divide this by 127, you're going to get this one.
So why don't you just use 1?
Yeah, that is the other easy way. That's
Can
correct.
you show it that way too?
So if I did this, I'll erase this. Okay? Think about this. What is this? A dot B is what? A dotted with B divided by B, right? What is, so can I write this as A dotted with B divided by B? Right. What is A dot with B? It will be 1392 divided by B is 127, which is 10.96. Okay, got it? You have to understand what this means physically. What does it mean physically to you? Hmm? What does projection mean? See, what does projection of this mean?
That's the length of A, but in
Exactly. The shadow length of A. You understand? The shadow length of A, in that, the shadow is this. If you're leaning like this, the light projected is, the ray of the light projected is perpendicular to the surface. And your length, your shadow length, you can simply calculate. That is what this is. You got it?
For the angle,
Hmm.
you did cosine 1392 or 19. That's I got 99. 99. Is it the inverse? Or?
Yeah, inverse.
Okay, that's why I messed up.
Okay? You got it?
Yeah.
Now, what is the projection of there are certain things you should know here, okay? And this could be a trick question, this could be a 1-point quiz question. Alright? What do you know about the length of A? In terms of this, what do you know of the length of A? Can you make one statement about the length of A? A correlation or a comparison statement? With respect to this, what do you know of the length of A?
For every one unit vector of.
No, that's a little, I'm just asking a comparison. Maybe not that complicated. A is longer than this. A is greater than this. Does that make sense? The projection will always be shorter. Or at max it will be equal. If this is parallel to this, it will be the same. Got it?
Yeah.
Now, what is the projection of B on A?
No.
No. I'm not asking. Now I'm not asking the comparison. I'm asking the how you compute projection of B on A. You do? I'll just say B dot A. Right, you're right. You got it?
Page is this in the book?
It's example 1.2. And the material is before that, the projection material. Okay. So this will be again 1392 divided by 9, right? Because your A dot B dot A is equal to A dot B. We know that, right? So, is this clear? The projection. You'll have a question on this on your exam. So make sure you learn this. Okay.
Does that mean that A over magnitude?
Hmm?
Does that mean that A over magnitude?
Right. That's magnitude. So magnitude. I have discussed this in the first lecture. Again, I want you to go and review the lectures as many times as you can. I've started uploading. I've uploaded the previous 2 lectures. You will fail the course if you don't keep up. If you try to do other things in class, if you're on cell phone, you will fail the course. Doesn't matter if you're graduating, you won't graduate. Okay? I cannot warn you enough. Alright. I'll do another example. I'll show you how to manipulate vector. Okay, we'll have a problem like this. There is a problem like this on your assignment, first assignment. So given E cross B cross A cross B cross C. Okay, all these are vectors. Can you express this as a dot product using back minus cap rule? Do you solve inside out or outside in? Inside out, that's, you know that, right? So let's say, can I write this as E cross B cross A cross G? What does G represent? B cross C, where G is B cross C. Okay? Can I write this as E cross B cross H? This is H is what? A cross G, right? What do you know about this? How do you apply the back minus cap rule to this? You do?
You take D cross
D
D, and then E dot H.
back minus
H. And then E dot D.
right? So think about this as, how do you apply back minus cap rule? If you have A cross B cross C, right? The back minus cap rule applies to ABC. Okay? What is it? B A C minus C A B. You understand? Now you just have one-to-one correlation. A is E, B is B, C is H. And then you correlate back minus cap D. You get it? Simple?
Where are the laws?
Hmm?
I found the laws. When you made G represent B cross C, so
I have not changed. So this is a separate thing. Back minus cap rule, we have discussed this. This applies to any three vectors. Okay? And does it make sense? If you have A, B, C in this order, if you want to split it using dot, this is how you split it. You have A, B, C, you apply back minus cap. This is the rule. This is the mathematics. What we have done is we have taken this, applied this 1:1 relationship to this thing. What is A here? E. What is B? B. C is H. You have simply written it like that. Back minus cap. Then what do you do with this? You have B. Keep the original vectors as they are. Replace the E dotted with what is H?
A cross G.
A cross G. Okay? minus H. Sorry. What is H? A cross G. E dotted with D. Got it? I've just replaced H. I've replaced H here. I've replaced H here. Alright? What is this? E. How can I write this? How else can I write this?
As either you could just rotate
G dotted with E cross A.
shouldn't be A dot GE.
Hmm?
Shouldn't be A dot GE. You said it's supposed to rotate forward and the first one goes to last.
Right, so this one goes here. Okay? E goes here, A goes here.
Okay.
The triple
Why
product.
you rotate?
Huh?
Why you rotate?
I want to separate this G.
Okay.
You see?
You're trying to factor it out with the other.
So here it will be A cross. What will this be? B cross C. This will be E dot D. Okay? Now, we'll solve this part first. What is this part? B C BAC minus CAB and this whole thing E dotted with E. How do you solve this? The question you are asked is express it as a dot product. So all this is expressed as a dot product now. What needs to be removed here? The E cross A. You got it? How do you get rid of that?
You could still
You have G is G cross C dotted with E cross A. Okay. That's it. What is this? Now tell me, is it expressed as what is the output of this? Vector. See, that is what I am looking at. Okay, you have to. If you are with me, you'll know what I am asking. The output of this is a vector. Everybody understands that. There is no dot, right? It will not result in a scalar. The output of this, is it still a vector? Right?
Yeah.
The output of this is still a vector. Let's look at this. What is the output of this? What is this? Vector. This is scalar. The 2 in the parenthesis is scalar. But the scalar multiplied by a vector is vector. This? Vector. Vector minus vector? Vector. you keep doing that. What is the output of this?
That's a scalar.
Scalar, yes. So this would be, what would this be? What would this be? Scalar, scalar, but this would be vector. So you have, ultimately what you're getting is,
Here's a question about something. When you second to last line, you have the why did you put G in there?
because I wanted to simplify this. I wanted to get into, I cannot apply back minus cab rules to this directly.
Exactly.
I can apply it to this.
Yeah.
You supply to scale vector triple product. I wanted to get it into a vector triple product form. It is in a vector triple product form. So this is back. B, A, B, C. I applied and split it because ultimately I want the original vectors in the expression.
Yeah, exactly. So, because I understand that H represented A cross G, what I don't understand is why is G right there by itself now in place of E?
Where is G by itself?
It's the second to last line.
This one?
No, exactly.
This one?
Why is G right? Why is G placed right there in the next step?
Because this is a vector, right?
Yeah.
This, see, it will again become a triple product. If I put it back here, it will be A cross G cross. It will again become a vector.
Because that was H. That's what H represented. So you took H out and put back A cross G, correct? In that step. So in the next step, I'm just confused why was it E?
He said, explain to him how you rotated the E dot A cross G to G dot E.
No, I think you understand the
Yeah.
rotation part. You understand the rotation part.
Okay.
The cyclic rotation. I want to get the G out so I can substitute G.
Okay.
If I substitute G here, it will again go back to something like that.
Okay.
It will defeat the purpose of, you have to remove it out so that it is
Right.
by itself.
Okay. Okay.
So how does that answer more simpler quotes?
So let's say there is one more step to this. It will all be expressed as dot product. The cross will be completely removed. So that I need you to figure out. I will solve it. I can solve it for you, but I need you to figure it out as well. Yeah, ultimately, what you're trying is you have an expression completely in terms of cross product. You're manipulating it to get completely in terms of dot product. Got it?
And that's in 1.2 as well.
That is 1.3. There is another step here. Okay? What you need to do is you need to understand how to manipulate this. Okay?
You can just have the book.
Okay.
This one I'll erase.
But yeah, you getting this out the book, Dr. Sun?
Huh?
Are you getting this from the book?
Yeah, we can do it. We'll just do a little bit of kinematics and then we'll end this thing here. So if you understand what is kinematics, right? You've already forgotten what kinematics is? You understand? You don't remember what kinematics is? So let me just refresh your mind. What is dynamics? Dynamics is the study of motion, right? Motion of particles, motion of bodies. That is clear? Dynamics is split into kinematics and kinetics. So dynamics and statics are part of mechanics. So mechanics is split into statics and dynamics. Statics is study of
No.
structure, essentially.
Stable.
Stationary structures. Dynamics is study of motion, moving particles. Dynamics is split into kinematics and kinetics. Guys, don't be on cell phones. I'm telling you, you'll regret it. If you want to pass the course, don't be on. At least give me your full attention, your full commitment. It is going to be a very challenging course. If you're an ROTC, don't be kidding around. I know students who have quit ROTC because they couldn't pass this course. They had to quit. If you're on cell phone, you're going to get rid of that habit. Okay? So, if you have kinetics and kinematics, kinetics is what? Kinetics is study of, the definition says study of motion without taking into consideration the cause of the motion. What is the cause of motion? Force, right? So if you look at, Newton's law is very, very simple and very intuitive. What does Newton's second law essentially state, or his three laws states? What are they encompassing?
How much reacts after being moved? Like,
Right, so that's what it is essentially stating. It is essentially telling you about the motion and the cause of the motion. Does that make sense? Change in momentum is what?
Acceleration.
What is change in momentum?
Oh,
Motion. You agree?
yeah.
For motion to happen, there should be change in momentum. What is force?
That's how acceleration.
Understand this. This is very, very fundamental, very basic.
Force is
One is motion, right? What is force?
what's applied to velocity.
The cause of the motion.
Yeah.
Motion and cause of motion. How do you cause motion? How do you cause force?
Momentum.
You again do momentum. You see, those are interchangeable, right? You have to, that is the reason there is a need for the first law. A state, you have to define the state. And that state is called inertia. So inertia is, first law states inertia, right? So he's very, Newton is a very smart fellow, was a very smart fellow. So he defined inertia. So everything in the world, in the universe is either in a state of rest or motion. Is there anything between?
No.
So how do you change the state of rest? How do you change, what is rest? So if you are, or what is inertia? It's a state, correct? So you are in inertia, almost. When the class is over, what is going to happen? Your state is going to change. You're going to apply force. Your muscles are going to start working. You're going to apply force. So it is all about force and or motion and cause of motion. So motion, if you study the motion without the cause,
it's kinematic.
perspective of motion. What is studying motion without the cause? It's a perspective. Okay? You understand what perspective is? What is it technically? Perspective.
But how you come up with something?
Give me 2 words.
Relative.
Perspective, you have studied this. Coordinate system. Right? Think about if you're observing Earth from Earth. It's not moving, right?
Right.
If you're observing Earth from
Space.
Sun, it's moving. It's a perspective difference. That is kinematic. You're only observing. You're largely changing the perspective. If you're sitting in an airplane and observing the airplane, it's stationary. If you're in a control room and observing it in an airplane, it's moving. It's a perspective. That's what kinematics is. Now, understanding motion with respect to what's causing the motion. That is Does that make sense? Okay.
Yeah.
So when you're studying, I'll just finish with this. When you study kinematics, you study these 3 parameters. What is this? Position.
Is that an extra or
R. This is velocity.
yeah, it's a lot.
This is
Acceleration.
acceleration.
For position, is that an X?
R.
R.
R. Okay, so you're studying these 3 in the context of different coordinate systems. You see that? And you have to get used to this. It's as spacecraft engineers, as aerospace engineers, nobody else should have better understanding of this than you guys. Okay? And it's absolutely necessary. Can you understand position without understanding vectors? You see how limited, why this vector manipulation vector is so important? It doesn't make sense. It doesn't have value if you don't study these as vectors. And if you don't have the vector background on how to manipulate vectors, what does dot product mean? What does cross product mean? You will not understand it. And if you don't understand this, that's it, you're stalled. There is no point in trying to understand design a big plane or design a big spacecraft. This is very, very fundamental. You need to understand this. Okay? Any questions?